Some gene mutations cause awful, rare diseases. Others are being discovered that lend a few people the ability to resist common ones like diabetes, heart disease, Alzheimer's, and HIV. Such beneficial, superpower-like traits might spread to the rest of humanity given enough time. But why wait 100,000 years for natural selection to do its job? For a few $100s in chemicals, you could try to install these changes in an embryo in 10 minutes. That is, in theory, the easiest way to go about making such changes. It's just one cell to start with. Editing human embryos is restricted in much of the world, and making an edited baby is flatly illegal in most countries surveyed by legal scholars. But advancing technology could render the embryo issue moot. New ways of adding CRISPR to the bodies of people already born, children and adults, could let them easily receive changes as well. Indeed, if you are curious what the human genome could look like in 125 years, it's possible that many people will be the beneficiaries of multiple rare but useful gene mutations currently found in only small segments of the population. These could protect us against common diseases and infections, but eventually they could also yield frank improvements in other traits, such as height, metabolism, or even cognition. These changes would not be passed on genetically to people's offspring, but if they were widely distributed, they too would become a form of human-directed self-evolution, easily as big a deal as the emergence of computer intelligence or the engineering of the physical world around us. I was surprised to learn that even as He's critics take issue with his methods, they see the basic stratagem as inevitable. When I asked Ernov, who helped coin the term genome editing in 2005, what the human genome could be like in, say, a century, he readily agreed that improvements using superpower genes will probably be widely introduced into adults and embryos as the technology to do so improves. But he warned that he doesn't necessarily trust humanity to do things the right way. Some groups will probably obtain the health benefits before others, and commercial interests could eventually take the trend in unhelpful directions, much as algorithms keep his students' noses pasted unnaturally to the screens of their mobile phones. I would say my enthusiasm for what the human genome is going to be in 100 years is tempered by our history of a lack of moderation and wisdom, he said. You don't need to be Aldous Huxley to start writing dystopias. At around 10 p.m. Beijing time, He's face flicked into view over the Tencent video conferencing app. It was May 2024, nearly 6 years after I had first interviewed him, and he appeared in a loft-like space with a soaring ceiling and a widescreen TV on a wall. Urnov had warned me not to speak with her, since it would be like asking Bernie Madoff to opine about ethical investing. But I wanted to speak to him because he's still one of the few scientists willing to promote the idea of broad improvements to humanity's genes. Of course, it's his fault everyone is so down on the idea. After his experiment, China formally made implantation of gene-edited human embryos into the uterus a crime. Funding sources evaporated. He created this blowback, and it brought to a halt many people's research. And there were not many to begin with, says Paula Amato, a fertility doctor at Oregon Health and Science University, who co-leads one of only 2 U.S. teams that have ever reported editing human embryos in a lab. And the publicity. Nobody wants to be associated with something that is considered scandalous or eugenic. After leaving prison in 2022, the Chinese biophysicist surprised nearly everyone by seeking to make a scientific comeback. At first, he floated ideas for DNA-based data storage and affordable cures for children who have muscular dystrophy. But then, in summer 2023, he posted to social media that he intended to return to research on how to change embryos with gene editing, with the caveat that no human embryo will be implanted for pregnancy. His new interest was a gene called APP, or amyloid precursor protein. It's known that people who possess a very rare version, or allele, of this gene almost never develop Alzheimer's disease. In our video call, he said the APP gene is